first thing we need to be able to do before we start the trigonometry is label the triangle correctly. So we've got a right angle triangle here, and the side that's opposite the right angle is always the longest side of the triangle, which is called the hypotenuse. Now, the labelling of the other two depends on the angle that you're interested in. So if this is the angle that I'm interested in here, then the angle opposite it, the one that's going to be all the way over here, is going to be known very cleverly as the opposite. The other one, as it's often known, is the adjacent, and the adjacent is always between the right angle and the angle you're interested in. We're going to use that in the next couple of problems. Now, from all of these three things, we have what you call the trig ratios. And they are that sine equals the opposite divided by the hypotenuse. The cosine equals the adjacent divided by the hypotenuse. And the tangent equals the opposite divided by the adjacent. Collectively, this lot are known as SOHCAHTOA, which is sine is opposite over hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So now let's have a look at using that to solve some problems. So we are going to find x, which is the length of side BC, and we already know this side here. So first of all, we need to label them. This side is opposite the right angle, so this one must be the hypotenuse, and this side is the other one we're interested in. It's next to the angle and between the right angle, and it's not the opposite, so it's the adjacent. So now I'm going to go back to SOHCAHTOA, and I'm going to see which one of them has got in it the hypotenuse and the adjacent. Notice I've only labelled those two because I'm not interested in this one down here at the moment, so I'm just going to forget it. Hypotenuse and adjacent, well, hypotenuse and adjacent is in this one, so that's the cosine. So the cosine of an angle equals the adjacent over the hypotenuse. And now I'm just going to put my numbers in. So the cosine of the angle, which I know here is 64, equals the adjacent, which is just x, divided by the hypotenuse, which I know is 15. So from there, to work out the value of x, I need to get rid of the divide by 15. So I'm just going to multiply both sides by 15. That will get rid of the divide on the right hand side, and it'll leave me with, wrong colour, leave me with x equals 15 times by the cosine of 64. So I grab my calculator, 15 times by the cosine of 64, and to one decimal place, that tells me that x equals 6.6 centimetres. Here's another example. So find the side length of AB, which is labelled x again here. So I'm going to label this triangle. So first of all, this one is opposite the angle that we're interested in. So that's the opposite. And this one is between the angle and the right angle, so this one is the adjacent. So write out the SOHCAHTOA, and opposite and adjacent appears in the tangent. So tangent of the angle equals the opposite over the adjacent. So now let's put the numbers in. I know what the angle is, so instead of theta I can write in 58, and that equals the opposite, which again I don't know, but the adjacent is on the bottom and I do know what that is. So now I just need to get x on its own, find the value of the x, and to do that I need to multiply by 11 to get rid of the divide by 11. So from there I'm left with doing the same thing again. From there I've got x equals 11 times by the tangent of 58. So on the calculator, 11 tan 58, and that gives me 17.6 centimetres to one decimal place. Here's another example. find the length of side AB. So label the triangle first of all. This one is opposite the right angle, so this one is the hypotenuse. And this one over here is opposite the angle that we've been given, so this one is the opposite. Referring back to SOHCAHTOA, opposite and hypotenuse is the sine, so the sine theta equals the opposite over the hypotenuse. Now let's stick the numbers in. So sine of the angle, which we know here is 27, that equals the opposite, which is 7. So I do know that the opposite this time on the bit on the top, and the hypotenuse is the bit I'm after, which is x. So here I've just got to move it all around a little bit to get the value of x. So first of all I need to get it off the bottom. So to do that, I'm just going to multiply both sides by x. That will get rid of the fraction on the right hand side. So I'll have x times by sine 27 equals 7. And now to get x on its own, I need to get rid of the times by sine 27. So to do that, I'm just going to divide by the sine of 27 to both sides. That will get rid of the sine 27 over here, leaving me with just x, and on the other side we've got 7 divided by the sine of 27. So on the calculator, 7 divided by the sine of 27, and that gives you 15.4 to 1 decimal place. Final example, find the length of the side BC. So label the triangle again. This one is opposite the angle we're interested in, and x is between the angle and the right angle, so that's the adjacent. So have a quick glance at SOHCAHTOA, and the adjacent and the opposite appears in the tangent. So we know that the tangent of the angle is always the opposite over the adjacent. So we'll stick the numbers in, and we'll get tangent of 39 equals the opposite, which is 5.8, divided by the adjacent, which is x. So again, I don't know what the thing on the bottom of the fraction is, the x here, so I need to get it off the bottom of the fraction. To do that, I'm just going to multiply both sides by x, which will get rid of it from the right hand side and leave me with 5.8. And here I'm going to have x times by the tangent of 39. So now I just need to isolate x on its own by getting rid of the tangent of 39 from this side. So I'll divide by tan 39 to do that. That will make it disappear from over here, and I'll be left with x equals 5.8 over the tangent of 39. And I'll stick that into my calculator, so 5.8 divided by tan of 39, and we get 7.2 to 1 decimal place.